the I will give the floor to today's presenter, Alexandre, from University of Brasilia, who will talk about evidence in relation to the Fermi paradox. So, Alexandra.
All
Please.
right. Thank you. Let me just eliminate this meeting is being recorded here from my screen. So, all right. Thanks a lot for the opportunity to give this talk here. And the title of my talk is Evidence, Partial Justifications, and the Fermi Paradox. Here at the University of Brasilia, we have a group called the Group for Theoretical Astrobiology, Futures Studies, Big History, and the Philosophy of Technology. My talk will be like, let's say, a continuation of Christina's exposition last week. And I hope I will be able to go deeper in some of the topics she has introduced last week. So the idea of this presentation is to present or to reason about some formal properties of evidence in the context of astrobiology. And in order to perform this task, I will take the Fermi paradox as a main point of reasoning because the Fermi paradox is something, an inference connected with the notions of evidence and with detection. And I put here a definition of the Fermi paradox, which can be found in this book, The Great Silence, The Science and Philosophy of Fermi's Paradox by Sirkovich. This definition he calls the strong Fermi paradox, and it states the following: the lack of any intentional activities or manifestations or traces of extraterrestrial civilizations in our past light cone is incompatible with the multiplicity of extraterrestrial civilizations and our conventional assumptions about their capacities. I think this definition is very general, and the lack mentioned there refers to the fact that we do not have evidence of extraterrestrials because we are not able to detect them. Therefore, we can notice that the notion of evidence is pretty much similar or and connected with the concept of detection or detectability. Uh, Evidence, detection, and partial justifications are therefore studied here in the intersection of a broader environment provided by logic and by explanatory hypothesis of the Fermi paradox. So my idea is to study the concept of evidence in astrobiology from this perspective of the Fermi paradox, which I think is a very important problem we have to deal with recently. The explanation of why we don't have any detection of extraterrestrial life or extraterrestrial intelligence. So, in order to get started, let me think about general properties we find when we're studying the concept of evidence. Evidence, it's a kind of justification, and we have many types of justification. It's very usual to think that justification can be strong when it is proof in math, in mathematics, or proof in logic. When we provide a demonstration of a fact, of a proposition, that proof makes the proposition true and makes this proposition a necessity. So this we could call strong justification. And evidence would be a kind of a partial justification. Of course, we can understand the notion of evidence, as we saw in Christina's talk, from many different perspectives, but here I will take evidence in a very specific context. It is a kind of mechanism to connect us with the notion of truth, but as evidence is not mathematical proof, it's not so strong like mathematical proof. It's something weaker. And in order to reason about partial justifications, there are indeed some formal systems to deal with evidence, or let's say partial justifications. One is the notion developed by Sergei Altemov, the logic of justification, which I will not touch here. And the other one is it's to treat evidence, or to treat partial justification as a kind of operator. And this approach dealing with evidence as an operator, let's say inside logic, has been developed by the Brazilian logician Newton da Costa. And I think here da Costa provides a very nice idea on the differences between strong and weak justifications, and evidence is a kind of a weak justification. If we take this sharp as an operator for justification, of course, everything I'm talking about here depends of classical propositional logic, in the sense that we have classical propositional logic with regular and usual operators. And we add this kind of partial justification operator. And in a logic in which we have this property, sharp phi implies not sharp not phi, this property here means, according to da Costa, the consistency of a justification. So, of course, evidence does not make use of this property, because we can have contradictory propositions with a similar degree of evidence. And these cases appear very often when we are studying explanatory hypothesis to the Fermi paradox. So a justification without this property can be called partial justification. And if you check it out here, we could say that all these forms of partial justification can be modeled using a variety of different strategies. I have studied some cases of how to model partial justifications, which in some stance can be viewed as evidence. And the interesting fact is that if you take, for instance, I have a justification of phi, and I have a justification of the negation of phi, there is no problem to have this kind of situation. If you interpret phi as an astrobiological proposition or theory, it's regular and normal, especially if you do not have the W operator, you can justify something and also justify the negation. I will show you some examples in astrobiology in which we have this situation, because the notion of justification is a weaker one, right? And in this sense, uh, the relevant property of partial justifications is especially this one here. Well, notice that in strong justification, when justification means formal proof, uh, we cannot have this, because if phi is a theorem and you have a proof of phi, you cannot prove the negation of phi inside the same system of reference. Of course, if you prove a mathematical theorem, you cannot prove its negation inside the same system of reference. I mean, the same system, because you could, let's say, for instance, have some results in Euclidean geometry, and you can have the negation of these results in non-Euclidean geometry, but this is not the same thing that I'm stating here. I mean, inside the system of reference, inside Euclidean geometry, we cannot have a proof of phi and a proof of the negation of phi. All right, and for this reason, we can have sets with this special characteristic, a set uh, which contains a justification of something and a justification of its negation. And this is regular, and this is what occurs in astrobiological issues, indeed, when we find the opposite theories. Uh, and if you take now classical propositional logic and let ETI represents extraterrestrial intelligence or life or both, consider the following argument, which is nothing more than modus ponens, the famous modus ponens. If P means ETI exists, then Q means it is detectable. Notice here that detectable means detectable is possibility of detection. It can be detected. So if we have that ETI exists, therefore ETI is detectable. It can be detected. But what occurs in reality is that they are not detected. So in this sense, we would have a set. In the first premise, we have this, P implies Q. The second one is P. And of course, from this both we have Q. But what occurs in reality is the negation of Q. So I argue that for this reason, Fermi paradox, sometimes is said it's an apparent contradiction. No, it is a contradiction indeed. And if of course you would say about detection and detectability are different concepts, so of course they are different, but there are some unexpected results that can be very surprising. So as I said, the above set of formulas, which is not the unique formulation of the Fermi paradox. There are many possible ways to formalize the Fermi paradox, but that one I have presented is one of them. And in that one, we have this set because the two premises entails Q, but what in fact occurs in reality is the non-detection, in the sense that we do not have evidence for the truth of the proposition ETI exists. We do not have evidence. That evidence could generate a kind of detection and vice versa. So this set here, of course, leads to a contradiction. And concerning the issue and the difference between detection and detectability, I would call your attention for the fact that if we interpret detection as knowledge, then we could infer inside the environment of something called Fitch's paradox of knowability, the following amazing situation. If extraterrestrial intelligence exists, then it's possible to detect that ETI exists. And from this, we could infer by Fitch's reasoning that if ETI exists, then it's detected that it exists. But of course, they are not detected up to now. And in this special instance of Fitch's paradox shows that there is an interplay or a kind of equivalence between detection and detectability, which sounds very surprising when we're studying Fitch's paradox. It depends, of course, if you think knowledge as detection or there is evidence for something, then detection and detectability are the same concept. But of course, if you think the notion of detection and the notion of evidence inside a broader perspective, notice that let T be a theory on the Fermi paradox, and we can provide evidence, weak partial justification for T, and we can provide evidence for a theory which denies T. And in the case of the Fermi paradox, this is very usual. For this reason, we have a plurality of hypotheses explaining Fermi paradox, and these hypotheses are sometimes contradictory. This kind of contradiction occurs in virtue of the fact that we have only partial justifications. We do not have proofs, stable proofs. So I have here something from Michael Hart, which is, let's say, which appeared in this journal in the 70s, an explanation for the absence of extraterrestrials on Earth, absence double S, sorry. If there were, quotation, if there were intelligent beings elsewhere in our galaxy, then they would eventually have achieved space travel and would have explored and colonized the galaxy as we have explored and colonized Earth. However, they are not here, therefore they not exist. They do not exist. This inference is based in the case of no evidence. They would have colonized Earth. They would have probes, let's say, kind of von Neumann probes, and they would be here, given that they are not here, therefore they do not exist. This kind, of course, hair-earth arguments, there are many kinds of hair-earth arguments. This quotation here, indeed, is not usually taken as a defense of hair-earth hypothesis, but it could be interpreted as a hair-earth argument, not the usual one. And this one is based in the no evidence. We do not find evidence, so we should find evidence, but we do not find evidence, so we infer that they do not exist. Of course, this is not, if you take this environment here, you notice that it's impossible to provide the resolutions to the Fermi paradox. In the literature, we find many authors stating that they are proposing solutions to the Fermi paradox, but a solution to the Fermi paradox would be or to show that ETI exists or to show that they do not exist. So when we take this hypothesis explaining the Fermi paradox, we have to pay attention that we are only dealing with explanations for the situation of non-detectability. These explanations are not solutions to the Fermi paradox. This is very common, and it's a very uh, and it's very common to find this kind of confusion in the literature, where people explain why we do not have detection, and they think they are solving the Fermi paradox. It's not a kind of solution, it's just an explanatory hypothesis for the situation of non-detectability. To solve the Fermi paradox is something completely different. And of course, Earth arguments, they are contradictory with arguments using, for instance, Copernicanism. Uh, this Earth argument I have used here is based on the fact that we do not have any evidence confirming the existence of ETI. But from other perspective, we can have many explanatory hypotheses based on Copernicanism, which is something beyond evidence. And in Christina's talk, this was qualified as stuffs which cannot be falsified. And but I think the when we are studying evidence in astrobiology, we have to pay attention, especially to unfalsifiable theories, because otherwise, evidence in astrobiology is a chapter of the generic research on evidence in sciences. And in order to have something to distinguish between evidence in astrobiology from other kinds of scientific enterprise, we have to consider especially unfalsifiable theories. In this case, I would mention here the zoo hypothesis by John Ball. The zoo hypothesis, which states that in some sense we are uh, isolated from these technological civilizations. And the John Ball states that the zoo hypothesis predicts that we shall never find them because they do not want to be found, and they have the technological ability to ensure this. Notice here, we shall never find them. This means that evidence is beyond our scope. And the task of trying to find evidence would be in a scenario like the zoo hypothesis, uh, a kind of theoretical dream, because if we take the idea of John Ball, of course, the John Ball hypothesis has been reformulated and extended to the interdict hypothesis and other explanatory hypotheses on the Fermi. But this hypothesis, which I find a very good one, states that the ETI they are supposed to have technological ability to hide any kind of evidence we could achieve, And in the same direction, if we take the planetarian hypothesis, especially the one developed by Baxter, one possible resolution to the Fermi paradox is that we are living in an artificial universe, perhaps a form of virtual reality planetarian, giving us the illusion the universe is empty. Of course, the issue of evidence inside the planetarian hypothesis becomes quite equivalent to the issue of find evidence in the scenario of the zoo hypothesis. The planetarian hypothesis is a kind of simulation argument, which now is very famous under under the label of the simulation hypothesis in the article of Nick Bostrom. And but the planetarian, which is also a very nice explanation of the Fermi, assumes that possible K type 3 civilizations in the Kardashev scale in these both hypotheses here, we should have the presence of these K3 civilizations, which have technological ability to manage and to establish a situation in which we are not able to find evidence. In this sense, they are in a context in which every attempt to find evidence is useless. And evidence, of course, can also be this case here of Paul Wesson is very interesting. It touches the definition of the Fermi, the strong Fermi paradox, which I mentioned at the beginning of my talk, the definition of Milan Cirkovic. And here they state that ETI, they exist, indeed. They have ontological status. Indeed, here it's the singular. Extraterrestrial intelligence has ontological status, means it exists, but they are out of our past light cone, so they cannot be detected. So we cannot find evidence. Uh, evidence in this sense provides a partial justification which makes a given proposition approach to truth in a certain degree, in a certain probability. And the quotation here is that we are then alone in the part of the universe we can see and communicate with now. But if the universe is especially infinite and the probability of the evolution of life is finite, there must be creatures in other galaxies somewhere. There is extraterrestrials exist, but they are beyond the horizon. Uh, for our working group on evidence in astrobiology, I really think we have to take into account not only what is falsifiable, we have to go deeper and we have to understand the situation of evidence and detection inside this broader perspective containing this kind of explanations to the situation of non-detectability. And in this sense, important things to be taken into account is that partial justifications allow the plurality of contradictory explanatory hypotheses concerning the Fermi paradox without leading astrobiology to conceptual collapse. What I mean here, indeed, when we have contradictions, we let's say we have everything from contradictions, but with the notion of evidence, with the notion of partial justification, we can have contradictions, justifications, partial justifications of astrobiological theories without trivializing astrobiology. Astrobiology can still be consistent even if we have this kind of hair earth argument and Copernicanism and things like this. And I think evidence, as I said, should be studied inside a broader perspective, allowing some hypothetical situations. If evidence is taken only concerning empirical evidence based on our current level of technological sophistication and understanding, then the issue of evidence is in astrobiology is nothing new, but the regular evidence in traditional and normal science. And for this reason, I think that the notion of evidence, which is very rich, and this notion has different perspectives and it has different theoretical implications. But in order to study this notion, we have to provide an, let's say, overture for understanding this very complicated situation in which humanity now faces. Because we are supposed to have technology, we are supposed to be a very smart species, but at the same time, we do have this problem concerning the Fermi paradox, which I think is the most important open problem for humanity now. The universe is so big, so large, etc., and we still do not have nothing clear on the situation of what's going on. What we have is evidence for many contradictory explanatory hypotheses, and we should try to find a stable environment for reasoning. So thank you all for all your attention, and this is my message to the working group.
Okay, thank you. Very nice. Okay,
I'm not sharing.
Yeah.
Have
So let's open the floor. Who wants to be first? Christina.
I'm going to have a little speech disguised as a question, which is a usual thing in conferences. Okay. Just to drive my question with a little bit of context, like logic of justification basically started as a continuation of logic of proofs, basically starting from Gödel's work on how to give a proof for every mathematical statement. And the logic of proofs in the works of Sergei Artyomov and Melvin Fitting was derived as something related to the world around us, because you're not always going to have strict mathematical proofs for everything that's around you. And the first thing, I really like the idea of this being applied to astrobiology, because that's the perfect territory for that. So kudos for that. My issue here is, as a logician, I need to be the advocatus diaboli, and that is the logic really a good weapon to attack that? Mostly because if we were to take justification logic or any other non-classical model logic to talk about that, there's a couple of issues. Like, for example, the standard justification logic is basically JTL4. So that means you're going to deal with the T axioms stating that if you have evidence for something, then it's the truth. Append then for the T axiom in model logic. Can we really talk about having just a single evidence? That means the statement is true. I'm not really sure about it. Mostly because I don't think, and this is the thing I started talking about in my last talk, I don't think that all evidence is alike. Of course, you're going to have mathematical proofs and everything else, but not all of them kind of lead to knowledge equally. This is my first issue that I'm having. I would like all of you to kind of jump in with that. And if you're dealing with logic, you're going to necessarily include the T axiom, especially if you're talking with the doxastic logics and the epistemic logics that we talked about, like the Fitch paradox. My second issue here is if we interpret, as it has been said, detection as knowledge, this seems like a far jump, mostly because are we dealing with justifications here? They're kind of like evidence. Or are we dealing with knowledge? Because that's another logic here. We're dealing with epistemic logics that are dealing already with something as knowledge. And something of being knowledge, we would say it needs to be true. It needs to be justified. We already have justifications, but they need to be true. So does the Fitch paradox really help us here if we need to include another layer? So these are my questions. I'm not sure whether I got some things wrong, but I'm kind of skeptical about it mostly. I think it's a valid point, and I really adore the idea of justification logic being applied to this. I'm kind of jealous I didn't think of it first, but I'm having mostly issues with the truth of the statements.
All right. Concerning your first remark, whether logic could be a weapon to deal with evidence in astrobiology, I think yes. And you mentioned the case of the T axiom, which would be read as if there is a justification of phi, then phi. Of course, this is not valid if we are trying to reason about evidence in astrobiology. This is only valid for some mathematical truths, especially because in virtue of Gödel's theorem, you cannot have this property. Even for mathematical proofs, you cannot have this property.
Yeah, but can you then talk about the standard justification logic being applied to astrobiology if you're excluding the T axiom? You cannot.
If you exclude, so you have something weaker. And in this case, you can have situations in which you justify something and in which you justify the negation of the say you justify a property and you justify its negation. This is the main point in this one is what I call partial justification here, which is concerned not only with Artemov's idea, but with also Da Costa's idea. And we can have a notion of justification without the T property, and using this weaker notion, we can, Christina, use it to reason about evidence, not only in astrobiology, of course, but in science in general. We have the perfect framework to deal
But
with.
is it really perfect? I mean, you're kind of having like a paraconsistent flow here. Okay, yeah, I can prove something and it's negation in a way, but are you talking about the same ontology? Because I don't think like you could be talking about the same kind of justification and its negation for all of the types of evidence that are being held in science or in astrobiology in general, mostly because some are weaker and some are stronger. And I think like for the logic, for any type of logic, excluding, like you could just have J minus, that's it. You're still going to be having the issues of having the same type of operator being applied to different kinds of evidence that are not strong in a sense. So I kind of think like this is now a hunch now that we should go towards something fuzzy. Mostly because you're not going to have the same hierarchy of evidence everywhere, right?
Yeah, you were right. So even if there is, even if we cannot find a well-established system for this kind of situation, we can build one. We can construct a system which is able to accommodate the situations like this we find in the explanations for the Fermi's paradox. It is amazing because you have Earth arguments from one side, and they are contradictory with hypothesis which assumes the existence of advanced technological civilizations in the universe. And we can accommodate both inside astrobiological discourse. So I think even if we do not have a perfect system to accommodate this, but I think we already have, we can construct something. That would be an option. A system, and it also touches that point you mentioned about underdetermination, because
Mhm.
here I'm taking different evidences, justifying different theories. But we can also take the case of the same evidence justifying the different theories in the sense that one is the negation of the other. I think this kind of situation always occurs when we are studying astrobiology.
Yeah, that's
Concerning
something
your,
that kind of reminds me of the conversational logics in Polish schools, mostly that are like usually applied to scientific theories because you can talk about different theories providing the same evidence, or the same evidence for different theories or different evidence for the same theories. I like that idea.
yes, the idea that the evidence is weak, so it's perfectly intuitive. I have an evidence, but evidence does not connect me with necessity, but only with contingency. So it's normal to think that we can have an evidence for a
Mhm.
thing and evidence for the negation of this thing.
I also think that this system would function only in two ways. First of all, it should be a fuzzy thing. It should be a fuzzy logic.
It could be a fuzzy
And
thing.
second, I think it should be an agent-based logic, mostly because my evidence for you, this is talking about theory lateness and non-determination, is not the same as my evidence as a geologist, my evidence as a biologist, because there's a theory lateness. This is probably something that you're going to find in epistemic logics with different ages, K1, K2, K3, Ki, with different knowledge. That could also kind of bring you up to axioms of common knowledge and group knowledge and everything else.
For instance, Da Costa, he has a system for partial justification in which he eliminates the consistency of justification, consistency of evidence, because
Mhm.
evidence is not consistent. When you are in a court of law, a lawyer provides evidence for something, and the other lawyer provides evidence for the negation, and the judge has to evaluate what's going on. And because evidence is not consistent, it's not a mathematical proof. But concerning your second topic, the interpreting knowledge
Mhm.
as detection, here I think we have a very interesting uh, analysis of Fitch's knowability paradox because uh, if you take the verification principle according to which if phi is true, it's possible to know phi, and if you replace phi by ETI exists, and you interpret knowledge as detection, then you would have, if ETI exists, then it's possible to detect that ETI exists.
And that's
And
great, but I have the issue with the antecedent of the statement. That is, if phi is true.
oh yeah, yeah, yeah. But if it's not, if you say that ETI exists is false, so you are defending a kind of hair earth argument.
Yes, of course, but you cannot really. I think the main issue in astrobiology is you cannot kind of state neither that phi is true, neither that phi is not true.
Yeah, but
Because
okay,
it would
but
be easy. It would be easy to derive something like that, basic with basic modus ponens, but you cannot.
yes, but listen, ETI exists is a sentence. It's the most important sentence, which we have. We need to have an idea of the truth value of this sentence. Of course, if you say it's false, my argument does not apply. My argument is interesting. The case, the antecedent is true
Mhm.
if they exist. But because if there is no ETI in the world, my interest in astrobiology would not be the same, of course. I would not be interested in this area of research. My interest especially concerns the Copernicanism, not
Mhm.
Hare Earth arguments. In the case of Hare Earth arguments, I think it's a kind of pity that these arguments show up in the literature very often. So you find someone trying to defend her earth arguments. But if you take Copernicanism, you can jump from detectability to detection. And detection and detectability are the same concept indeed, which is amazing and which is very we do not weight this kind of connection. And this interpretation of the Fitch's paradox of knowability, I find it very, very interesting because, of course, you were showing I'm connecting knowability with the Fermi. Indeed, we can think that the Fermi paradox is a consequence of a special interpretation of the Fitch's knowability paradox when we deal with knowledge as detection. And detectability is the possibility of detection, which is not detection, but under the premise of Fitch's paradox, they become the same concept. I think this connection has to be explored in detail. I recognize that there is a connection, but I have to explore it further.
Mm-hmm. Okay. Thanks.
Thank you for your question.
Okay, thank you. Super interesting discussion. Do we have anyone else who want to follow up on this or post a completely new question or comment? Emma.
Hello, I pretty much just wanted to introduce myself because this is the first of these meetings that I've attended. I've just finished up a PhD at St. Andrews studying the portrayal of astronomy in science fiction. And I heard about this group from Julie Novikova, so I've decided to join. Not quite sure what my next steps are, but trying to stay in the field. So wanted to join and come along for these discussions. I haven't been able to make the last few, so this is the first one I've been at, but I'm very glad that this group has such active, fruitful, interesting research and discussions. So thank you very much for having me.
Right, thank you. Great. Yeah, the portrayal of extrasolar planets in science fiction sounds like a topic for another seminar, right?
Yeah, definitely. I was at the EAI Beacon conference in 2023, so may have seen some folks there as well.
Yeah, let's talk more about that. Anyone else on Alexander's presentation and the evidence issue? Maybe I can ask you, Alexander. You're talking about the Fermi paradox, which is dealing with extraterrestrial intelligence and also extraterrestrial intelligence that is kind of let's say aggressive and has supposedly taken over or should have, according to Fermi, taken over the galaxy by now. What if we try to like apply the same thinking on non-intelligent life? Can you say something about
Yes.
that?
Yes, indeed, the Fermi paradox, it deals not only with intelligence, but life in general. And I want to put a word here on the fact that I mentioned that Weston quotation, which he say, oh, sorry, Michael Hart's quotation, in which he says they would have colonized our galaxy. There are articles recently in the International Journal of Astrobiology which contemplates a feminist approach to the extraterrestrial issue, especially Konrad Zosek, and against the idea of colonization. Of course, not all ETIs would be engaged in colonization. This is a very anthropocentric view, which we think that they will colonize the galaxy, the whole galaxy. But in astrobiology, there are some researchers. I remember this one, Konrad Zosek, who wrote this article on a feminist interpretation of the issue concerning ETIs, on the fact that you said no intelligent life. This is a very big discussion on what is intelligence, etc. But in the case we have life, let's say, under our level of technological sophistication, the Fermi paradox applies equally well, because it's a question of detection of extraterrestrial intelligence or life, or both. So, but of course, if we take something lower than our level, so everything depends of us. The search becomes our problem. And us, humanity, we do not have technology. We do not have, up to this moment, sufficient technology to anything. We know how to manage more or less Earth, more or less our neighborhood, but from a profound perspective, we are a species without technological developments. We are at the beginning of our history, indeed, and we are starting in the cosmic scene. In the case of civilizations or only life, levels of technological ability which are below our level, the Fermi paradox still applies, but this case is not so interesting. It would depend of our capacity to recognize, to detect them, assuming the way to measure this based on technological development. I think it's very complicated for Earthlings to understand something, because we have many wrong ideas about our capacities, and this is a very disturbing fact. In the case you have mentioned, Eric, I would say the Fermi still applies, but the case is more humanity dependent, because we should be the responsibles for detection, for evidence, for everything. No, no, yeah.
Thank you, Brian.
Could it be a matter of time scales? I mean, our civilization has not really been on a level for more than 100 years or so. And a time that takes light to travel around is quite long.
Yes, this makes everything even worse. Yeah. Our situation is not a good situation. We have to be very humble and stable. emotionally stable to reason about the cosmic arena. It's very complicated for us. So I think we need to use these stable tools to reason, more or less reason about what we can achieve, which is not too much.
Okay, Birger?
Yeah, no, I was thinking on this with timescales. That I think that's a very good argument, and perhaps one can envision really, really long timescales. I guess you all know that there are these people who planning to, or it's a wild idea. It's still like brainstorming, but they're thinking of sending a light sail to Alpha Centauri, our neighbor star system, and it would take 20 years or something like that for a light sail to arrive there. And what they're thinking of is to put in resting spores of bacteria that could survive in space and could land on an habitable planet on our neighbor solar system. And if things work out well, after 4.5 billion years, evolution has gone through the same steps as on Earth, and you will have a civilization there that was planted there by another civilization. Okay, I agree. All this is brainstorming, but there are people who are seriously trying to work with this and look at the technical problems. So I think with these new developments, one could perhaps put new perspectives on this Fermi paradox, that maybe another civilization has already sent out resting spores all over the galaxy, and it's just a matter of time. Okay, I'm speculating wildly, but I'm just giving another perspective, or that's it. Or do you have any thoughts of that whether civilization can spread in this way, if the Fermi paradox has somehow accommodated that the spread of civilizations throughout the galaxy could take place in this way? Has anyone considered that in the context of the Fermi paradox? That's my question.
If you take that book, Stephen Webb's famous book, he exhaustive list 50 solutions, 75 in the recent one, solutions to the Fermi paradox. This one probably is there in between all those hypotheses. And the Milan Tirkovic book, The Great Silence, I think it's the best book we have on this situation. I don't know exactly how to deal with these things concerning probes, von Neumann probes would be everywhere in our galaxy if they have existed, but they are not here. They would colonize the whole galaxy quickly, but they are not here, so ETI does not exist. Well, I don't know. I have to think about it.
Okay, Brian?
Yeah, there's a lot of interesting questions with the Fermi paradox. I mean, also, what are they interested in colonizing? Are we too selfish when we think they want to colonize a planet like us? I mean, there could be there's reason to think that the biological being are not going to survive in space anyway. So the biological heaven we have here might not actually be of interest for their own personal needs, but could be like the zoo hypothesis. Oh, there's an actual rare planet with biological life, so we're not gonna convert that into energy. Instead, we're just gonna enjoy watching it or something.
Yeah, I agree.
So yeah, like there could be many answers to the Fermi paradox, I guess.
But what is important is that they are only explanations. In the literature, we see people saying, I propose a resolution to the Fermi paradox. They are not resolutions, they are only attempts to explain the situation of non-detectability. It's very important to notice this fact, because what is to solve something? To solve something is much more complicated. There are only two ways to solve Fermi paradox, or to prove that they do not exist, and we do not have technological ability to do this right now, or detecting them. These would be solutions. Other stuffs are based only on explanations or answers, let's say, in your sense, Brian. And check it out, this paper here on the feminist approach to extraterrestrial intelligence. I found this paper very different and interesting, because colonization is anthropocentric issue, maybe, but when we are studying the Fermi paradox, something has to be valid for all extraterrestrials, assuming they exist, not only for one. This is a contribution of Chikovitz's book. So an explanation should satisfy non-exclusiveness, because of course one of them is not interested, but is this valid for all of them? So an explanation cannot be based on one case. It should satisfy some assumptions, or sorry, some restrictions. Non-exclusiveness is a very strong one. When I explain something, I have to explain it for the whole population of ETI, not for one or two. It should be it needs to have a universal validity. It's the same like the transcension hypothesis of John, forgot his name, John Smart. John Smart has this transcension hypothesis, which he published in Acta Astronautica. No, sorry, Acta Astronautica. He shows there that advanced civilizations leave the universe towards black holes and things like this. But okay, one advanced civilization could do this, but are all advanced civilizations in this way? And the nice article of John Ball provides a lot of keys and clues for all these discussions. But the Fermi paradox is the most important open problem recently in science. It's a very, very important problem. And we are very far away of explaining it. Even if assume that we find ETI somewhere, even if finding ETI, Tsukovich states that the Fermi paradox would still be there, because 1 and 2 concerning the universe is almost the same thing. Even if we find a novel civilization, the Fermi paradox persists.
Yes, and as you point out, even if, I mean, it's a standard argument against like the zoo paradox and also discussions like the anthropocentric assumption that it only takes one, even if 99.999 technical civilizations out there are uninterested in communicating with us, it only takes one to break that, for this explanation to fall apart. So I was going to ask you, you know, of course, about Robin Hanson's great filter, and the explanation that there is a great filter, saying that once you reach some level of sophistication, it could be behind us or it could be in front of us, then it will all break down. And the of course negative for us solution will be that this great filter is ahead of us, and maybe it shows that once you get to this level of technical civilization that you can colonize the galaxy, then you kill off yourself. What's your take on that, Alexander?
Well, I think the great filter idea is a very interesting idea. My personal opinion is that there is not only one filter, but many. We have filters. Certainly, we have already passed through one of them, but there is another one that we still have to reach. I have a conjecture about what is this filter, but I'm still preparing my argument. I would say we have two or three filters to reach up, touching, let's say, high levels on a Kardashev scale. But my argument is not mature enough, is not, let's say, advanced enough to state it here. I think it's a very nice point, and we have a plurality of filters. Probably one of them we are red crossed, but there is another one waiting for us in the deep future. In the deep future, not waiting for us tomorrow or in our lives, but in the deep future. I mean, deep future is like cosmological decade. It's a concept by Fred Adams. Let's say in the next cosmological decade, not in our times. It's a cosmological decade. It's a very nice idea of Fred Adams and Laughlin. Cosmological decade, it's a kind of a logarithm, and we are now, it's like 10, 10 power 2, 10 power 3, 4, 5. Each jump in the power is a cosmological decade. We are now in the 11 cosmological decade, I think 11, because it's 13, almost 14 billions of years. That's it's something like 10 power 11. In the next cosmological decade, that would be a deep future. In the deep future, I conjecture we have another filter to pass through. And I have a conjecture about what this filter is, but I cannot tell it now because it's not precise and clear. And there are a lot of holes in my explanation, which I'm trying to understand. Because to explain the history of humanity, we have many models to explain the history of humanity. But to explain, let's say, the history of God, that's very complicated.
Thank you. Anyone else? I think I would like to ask, because I agree with you that evidence can be, not proof, but evidence can be both in favor of and against, and we can have evidence pointing both in favor of and against something at the same time, in like a Bayesian sense, that we can find some things that increase the probability that a certain planet or something is inhabited, and also we can find something that points against it in principle. But I was thinking, what kind of evidence or discovery rather would serve as evidence against that a certain planet or moon is inhabited. I can imagine that if we find something that we count as evidence in favor, right? Let's say we find methane in the atmosphere of a planet, and then we find a possible geological source for that methane, then we have found something that is evidence that's lowering the negative evidence in the sense that it lowers the positive evidential value. But what would count as evidence in a more pure sense, evidence against a world as being inhabited? Other than that, we haven't found anything yet, but something more substantial.
Evidence for something, it's easy to say. Biosignatures, technosignatures, or possible forms of direct contact, or if you take that Hynex classification. But evidence against, we are not in position to say, given our technological level, but in our future cone, if we develop technology in such a way that we will be able to check out the whole universe and to be sure that we understand everything, we are almost close to omniscience in our deep future. At this moment, we could say what evidence against is. But now it's very difficult. I have no idea how to treat evidence against. We only would be able to say official words on this in a moment in which we run the whole universe. In this moment, we run, we do not run even Earth. So evidence against would be that it's very difficult to say.
I'm sorry, but is it really difficult? I don't think it's really difficult. I think it's physically impossible. And there's a difference, mostly because like the observable universe is, I don't know, more than 90 billion light years in diameter. But you since it's expanding, it's moving away from us, and since the whole space itself is expanding, it's often faster than the speed of light. So philosophically and physically, there wouldn't be a way for us, if we were to justify the knowledge of our own physical laws, to actually check it all, right?
Yeah, but listen, imagine a situation in which humanity is very, 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 very high developed technologically in the deep future, not tomorrow. And in this situation, we run and we know almost or all the universe. In this case, it would be feasible to provide evidence.
Do you think, since like you would be kind of, I mean, okay, in some possible world, yes, but you're still limited by the cosmic event horizon between, like, beyond which
But
no information can reach you due to the like rapid expansion of space, and
we are
that's going to set the boundary.
But Christina, we are limited now, given our current scientific knowledge. We do not know what will happen in the future with humanity. We can reach levels of technological development and scientific understanding of the universe, which transcends all limitations we are supposed to have now. Of course, I think using logical possibility, not physical possibility.
Yeah, logically, of course, I totally agree.
Yeah.
I just think that it kind of includes a violation of physical laws. So there's a
Yes,
difference between the perspectives. Yours is logical,
yes,
more
yes,
mine is
yes,
a
yes.
metaphysical one. Yes, thanks.
But I think in this group, we have to take into account the logical possibility, not physical possibility. Otherwise, our research here is a chapter of evidence in science.
I mean, if we're dealing only with logical possibility, then we can stop this because in some possible world, aliens do exist. So it's kind of easy to say it like that. But yes, I agree. It's a valid notion. We should include it, but still, in order to be scientifically inclined in the paper and everything else, there is a physical limitation, unless we derive a new general theory of relativity, which is not going to probably be the case in the next couple of weeks.
Of course, to reason. Now we take into account physical possibility, but we cannot be blind concerning logical possibility. When I mean logical possibility, I mean logical possibility in the good sense, not in the caricatural sense, of course, right?
Okay. Any more comments, questions?
Just one.
Okay.
I mean, interesting when you're talking about the deep future. I mean, if you look at fluids mixing together, you can talk about whether they are homogeneous or inhomogeneous, well mixed or not well mixed. When you're saying deep future, you're kind of saying, okay, now we have expanded so we can know everything, so to speak. But that could, if you turn it around, be explaining the Fermi paradox today, that, like we said before, timescales. I mean, at what timescales does we need to work on?
Uh, I use I think I use a kind of flexible cosmological decade because if we put 10 power, that's too much for us. I would replace the base 10 by 2, 3. I use this kind of time scale. I would mention this article here, measuring and classifying levels of futures. In this paper, you find what I think about which time scale has to be used. I think it's a methodological issue, which I do not know precisely which one we have to select. I think 4, maybe base 4, flexible cosmological decade, 4 power n, eta, and eta is the cosmological decade. I think 4, base 4 sounds good for this time scale. In this paper, I have tried to suggest a time scale for humanity because cosmological decades like Fred Adams, that they are this time scale is very useful for the universe, not for us, which are almost non-existent beings considering the whole universe. But for us, maybe base 4, base 3, 2, flexible cosmological decade, but a future more, let's say, reduced to our reality. Because for us, it's very difficult. 100 years for us is something already complicated. So, time scale, we have to decide together what is the best time scale. Alone, I'm not able. And I hope this group, I'm sad that Tony Milligan is not here because I thought he would be here. He said that's projects of writing something which really interests me in the context of this group. I think we are able to write something interesting on the evidence in astrobiology. combining all these brains, a piece of paper can appear, maybe.
I think he will turn up in later seminars. It was very interesting this too. Okay. Anything else, or are we in Europe ready for dinner and Alexandre may be ready for lunch?
For lunch, yeah.
Then I'll thank you, all of you, and especially Alexandre for the presentation and for the discussion. Yes.
Thank you all. Thank